In this section, we want to talk about the concept of diminishing returns. But before we get into that, we want to start off with talking about the idea of rate of change, or more specifically, comparing the rate of change of two functions. We have graphed here a function f of x and a function g of x. Both of these functions are increasing. As we read the graph from left to right, the function values are increasing, which means that f prime of x, the derivative function evaluated at any point, which would give us the instantaneous rate of change of that function, would be greater than 0 because that function is increasing. If we evaluated g prime of x for any value of x, that derivative result would be positive because we have an increasing function. But it's pretty obvious to tell that our function f of x is increasing much more rapidly than our function g of x. So there's the concept of a function increasing or decreasing, having a positive instantaneous rate of change or a negative instantaneous rate of change. But there are also different rates at which a function can be increasing or decreasing. Now let's look at this graph, where what we have is a function that we'll call s of x. This function has 3 points plotted for us. And if we just trace down to the x-axis, we can start carving up some different pieces of this function. So this first point that we have plotted, from there and anywhere to the left of that, our function s of x would be negative, s prime of x would be negative. The instantaneous rate of change of that function would be negative because as we read that graph from left to right, the function is decreasing. From that third point and anywhere on, our function s prime of x would again be negative since our function is decreasing. But in that interval in between the first and third points, s prime of x would be some positive value. The instantaneous rate of change of the function on that interval is positive because our function is increasing. But that rate of increase is not constant over this interval. And in fact, if we zoom in here, we can see this even better. I'm going to highlight a couple of squares. So that we can focus in and see what the rate of change of that function looks like over a fixed interval. So if we look at this first square that I drew, we can see that the graph enters that square kind of at the bottom left corner and exits more or less at the upper right hand corner. So that's a visual representation of how quickly that function is increasing because we can see how much the function value changes over the width of that square. If we highlight another square, now we see that over that same fixed interval, our function is entering that square, not up at the top left-hand corner, but much, much higher up, much closer to that upper left-hand corner. And it's still exiting close to that upper right-hand corner. So as we look at that square, that interval from left to right, our function value hasn't changed as much. The function is still increasing, but the change in the function value is a lot smaller. What we have is this middle point plotted. We refer to this point as the inflection point of this graph, or at least one of the inflection points, because what's happening at that point is that while our function continues to increase, we have a more rapid rate of increase over the first half of this interval than we do over the second half. So as we hit that inflection point, our rate of increase, we're still increasing, but we start increasing, our function value starts getting larger at a slower rate. There's less increase in the function as our x value continues to increase. And that's going to be the idea that we carry over into the concept of diminishing returns.